Hello and welcome. So we're given the links to the circle below. Solve for the radius. Now this is kind of an interesting predicament we're in here. A fun predicament. So first off, let's talk about a few chord properties. So we have the center of the circle, and we have a radius right here. Okay, because remember, radius is anywhere from the center of the circle to the outside. So you actually have two radius lengths here, from D to T and from D to G. Now, whenever you have a radius that intersects with a chord meaning 2 points on a circle with a line between them, that line is called a chord, right? So the yellow one is a chord. So whenever you have a radius intersecting a chord at a right angle, then that means that these two lengths are the same. So that means that first length is 10, this is also 10. Okay? So now that'll kind of help us a little bit, because what if we were to just take this radius and kind of rotate it a bit onto R? That means that would also be a radius too, right? Yeah, it would. Which means that that would also be the same length as the other two radii that we have written there. And the reason why we want to write it there as well is because what is this? A triangle, specifically a right triangle. You can use Pythagorean theorem to find your missing lengths. So I'd say, okay, well now we know that Pythagorean theorem, if you have legs A and B and hypotenuse C, that's A squared plus B squared equals C squared. And you'd say, all right, well, let's figure this out. We're also given an 8. How does 8 help us? Well, we know that if we have some length here, I'm going to call that length x, that means our radius, the entire line right here, is going to be x plus 8. And that helps us out because that's no longer just an r there. Now that's x plus 8. That's a little more quantifiable. And if we wanted to finish out, now we have something written down for all three sides of our triangle. Right? We have one leg, which is x, so x squared, plus our other leg, 10 squared, equals our hypotenuse, x plus 8 squared. Booyah! Now you have a relationship, an equation written out, and now you can solve for x. And once you do, that'll help you back solve for your radius. So let's keep going. So x squared is just x squared. 10 squared is 100. And remember, once you have a parenthesis squared like this, that means you have two of them there, an x plus 8 and an x plus 8. So then distribute those parentheses out. So x times x is x squared. X times 8, 8x, 8 times x, 8x, and 8 times 8, 64. Okay? And then just start simplifying this down, right? Add your like terms. So we have x squared plus 100 equals x squared plus 16x plus 64. Now, our goal is to try to, once we see anything with squares, try to get everything onto the same side. So I'm going to move my x squared and my 100 over. Okay, so the x squareds were moved over to the left, 100 moved over right from the left, so we have 0 equals now. And on the right side, we see something super interesting and kind of exciting happen, where we have x squared minus x squared, 0, right? Those cancel out. So now that just leaves you with the 16x, and 64 minus 100 is negative 36. And now that's it, right? You don't have any more x squared, so this is just a matter of getting your x by itself. So I'm going to move that 36 over. Frankly, if we didn't even subtract 100 in the first place, that might have been a little easier. Okay, so now we have 36 equals 16x. Finish it out, right? Divide by 16 both sides, and we get x equals 36 over 16. Now, our answer here says, if needed, round to the third decimal place, so it's not looking for a fraction, nor is it looking for this simplified fraction, right? Because this would simplify to at least, let's just divide by 4, so that would be 9 over 4, right? It's not looking for that simplified fraction, it's looking for the decimal, so out your calculators, and they do 9 divided by 4, and we end up with 2.25. That's an exact decimal. There's nothing more we can do there, so 2.25 goes into your answer blank. Now, if we had more digits, then round to the third decimal place. Like, look at the fourth digit and say, all right, does that round up or down? Add it to the third decimal place, or leave it alone. Okay? All right, so there you have it. That is your... Oh, wait. That was terrifying. I was very close. That is your x. Oh golly, that's not your radius. We almost made it a little bit of a gaff there. So x plus 8 was the radius, right? We just solved for x. X is this length right here. But we didn't want x, we wanted r. Which means that we said, okay, well, we said r, right? Remember back up here, we said r was x plus 8. So all I have to do is take our 2.25 and add 8 to it. 10.25 would be your radius. Oh man, directions are important. 'Tis why we read them. Alright, now at this point you are officially done, and that would be your true radius. Thanks for watching.